we are given a gradient function, so f prime of x, as px minus 4, where p is a constant. We're also told the curve, so the original function, passes through 2 particular points. And we're asked to find the equation of the curve, right, where the curve is just f of x, and we are given f prime of x. So firstly, recognize if we're given the gradient function and we're looking for the original function, we need to anti-differentiate. And you might hear the word integrate as well. Cool. So let's just also have a think about what the gradient function looks like. So px minus 4, that's a straight line. We don't know if p is positive or negative, so it could be, a positive line or a negative line. What we do know is when we anti-differentiate, we will expect a quadratic. So f of x is going to be a quadratic equation, or a quadratic function. Do we know which one it looks like yet? No. At least we know where we're heading. Cool, so step 1, let's try anti-differentiate. So we're given the gradient function is px minus 4. So the original function, right, we're anti-differentiating with respect to x. So the first term, we will add 1 to the power, so that becomes x to the power of 2, and we will divide by that new power. So the antiderivative of px is px squared minus 2. The antiderivative of minus 4, the same rule, right? There's technically x to the 0 there, right? Because x to the 0 is 1. So again, we add 1 to the power, so it becomes minus 4x, and we divide by that new power. Cool. Or another way, just to remember it, when you anti-differentiate a constant, it becomes that constant with x, or the variable that you're integrating with respect to. Right? And we don't need to write all those ones. Alright, are we done? No. Right, when we anti-differentiate, we have this integration constant, which we usually use C for constant. And why we have that is if we go the other way and we differentiate, the derivative of a constant is 0, but the antiderivative of 0 could be any constant, right? It could be 0, it could be 1,000, we don't know. So that's why we add plus C at the end of the antiderivative. Right, so just quick recap. So this was our gradient function. We got the antiderivative and found the original function. However, you'll notice there's a few unknowns here, right? We have P and C. Very PC. Okay, anyway, we need to find those, P and C. What else are we given? Well, we are given 2 points, right? An x and a y value, or an x and an f of x value. So we can substitute those points into our equation and solve for the unknowns. So let's do that now. So let's use equation 1, we'll call this point 1 and this point 2. So substituting in 4 for x and 12 for f of x. So in for f of x goes 12. We have p, x is 4 squared, all divided by 2, minus 4 times x, where x is 4, plus c. Cool, so let's simplify that a little bit. 4 squared is 16, divided by 2 is 8. minus 16 plus c. And I'll solve for c. I'll put everything on one side and c on one side by itself. So I'll subtract 8p and add 16. So that's 28 minus 8p equals c. Alright, so that was equation 1 using point 1. So now let's find equation 2 using our second point. So like before, n for x will go negative 6, and n for f of x will go 2. So we have 2 equals p times x, which is negative 6 squared over 2, minus 4 times x, which is negative 6, plus c. Like before, let's simplify. Negative 6 squared is 36. 36 divided by 2 is 18. Minus 4 times negative 6 is positive 24. And like before, I'll take everything to the left apart from c. So subtracting 24 gives minus 22. Subtracting 18p gives minus 18p. Alrighty, so this is starting to look good. We have two equations, right? Equation 1 and 2, and we have two unknowns, c and p. What that means is if there's a solution, we can solve. Right? It's called simultaneous equations. So solving 1 and 2. And so the reason why I put or rearranged for c is so that I can equate these two equations, right? It's called substitution. So n for c will go 28 minus 8p. So let's do that now. So 28 minus 8p equals minus 22 minus 18p. And you see, by substituting like that, we have eliminated c from our equation. So we've simplified it to one equation, one unknown, which we can solve. So I will add 22 to both sides, so that's 50. I will add 8p to both sides, so that's minus 10p. To find p, we'll divide both sides by negative 10, and we get p equals negative 5. Awesome. Now, to get c, we can use either equation, right, equation 1 or 2, because we now know the value of p. So I'll use equation 1. So 28 minus 8p, where p is negative 5, is equal to c. So that's 28 plus 40, which is 68. So c equals 68. So now that we have our values for p and c, we can go all the way back up to our orange star, right, our f of x, and find the final equation of the curve. So we are left with f of x is p times x squared, where p is minus 5, x squared over 2, right, we can leave that as a fraction, minus 4x plus c, where c is 68. And that would be our final equation for the original curve. Alright, so just stepping through this one more time while it's fresh. So we were given a gradient function. The tricky bit here was that it had this unknown constant. But just like normal, we found the antiderivative, so f of x. However, we had two unknowns. So we always have the unknown plus c. However, now we also had the constant p. And so what that meant is we needed to find two equations to solve. Right? But if you just got up to that orange star, right, finding the original equation in terms of p and c, that would be achieved. Right? However, to get merit, you then needed to find the two equations, 1 and 2, solve for P and C, and then put it back into the equation, right, to find the final equation.